So if you remember from, from the second or third week of trigonometry, right, we had talked about two reciprocal functions, the secant, which is the reciprocal of the cosine, as you see here. Secant is 1 over the cosine, and its buddy, the cosecant, which is the reciprocal of the sine. Okay? So what's important to understand about the graphs is because these are reciprocal functions, everywhere the cosine equals 0, if the cosine ever equals 0, that means the secant will have an asymptote. Right? Because you can't have 1 over 0. So that's an undefined value. And every time we have an undefined value, our graph has an asymptote. Okay? So it's really important to understand that where your parent function, in this case cosine, wherever cosine equals 0, your secant function has an asymptote. So when we go to graph these things, we're going to be graphing points from the cosine. Because wherever cosine is 0, we're going to have an asymptote, and that's an important part of your secant graph. Okay, so notice here is an example of your secant graph. This dashed line here represents your cosine graph, right? This is just normal cosine. So let's talk about some things that we need to understand about graphing cosine. Number 1, cosine always, if it's a positive, always starts at a maximum value. So in this case, cosine with an amplitude of 1, it starts 1 unit above your midline. So your midline is the x-axis, unless otherwise moved. So cosine starts 1 unit above your midline. Cosine also ends. So one complete cycle is from a maximum to a maximum. So at 2 pi, which is your standard period for cosine, also for secant, we're going to also be at another maximum. Okay, exactly in the minimum, in the middle of your two maxes, we have a minimum point. So cosine starts at a max, ends at a max, and has a minimum in the middle. And our other points for cosine are halfway between your maxes and your mins. Exactly in the halfway, we have a 0. That's where your graph crosses that midline. Okay, so as you see, everywhere we have a 0 for cosine, your secant graph has asymptotes. Okay, this is going to be an important part of how we sketch our graph, is we find the zeros of your cosine and we put in asymptotes wherever those happen to be. Okay, something else hopefully you notice is the graphs go up, right, in a parabolic way from a maximum point, and they go down at a minimum. So the other points that we're going to find from our cosine graph are the maxes and the mins. From a max, our graph goes up. From a minimum, our graph goes down. Okay? So graphing sine and cosine are an important part of being able to graph secant and cosecant. Okay, so notice over here on the cosecant graph, the cosecant function. The cosecant is the reciprocal of your sine. So everywhere sine is 0, your cosecant function will have an asymptote. Okay, which is why it's important to know how to graph our sine graph. So sine always starts where your, I guess at the origin, but it's where the y-axis crosses your midline, right? The midline here is still the x-axis. It has not had a vertical shift. So sine starts at the origin, has a 0 at the start. It has a 0 at the period, so it has a standard period of 2 pi. And it's 0 in the middle. Okay, so this is our standard graphing for sine. 0 at the start, 0 at the end, and 0 in the middle. So notice that's where your asymptotes are. Your asymptote for cosecant is everywhere that sine crosses the x-axis, or sine has a 0. And then also, wherever sine has a max, we have an upward facing graph. And wherever sine has a minimum, we have a downward facing graph. Okay, always that parabolic shape. These aren't really parabolas, but they have that parabolic shape to them. Okay, so it's important to understand when we're graphing secant and cosecant, we're going to get the points, we're going to get the zeros, we're going to get the maxes, and we're going to get the mins from your sine and your cosine graph. And we're going to use those zeros, maxes, and mins to graph asymptotes and upward facing and downward facing graphs. Okay, so let's practice some of these. So some vocabulary. We don't call this an amplitude anymore for cosecant and secant, as well as tangent and cotangent. We call it a vertical dilation. Right? It has been stretched rather than amplified. So it's called a vertical dilation. The period is still found like we find every other period, 2 pi divided by your b value. Right? And the b value is the thing in front of your x, right? A times trig times b parentheses, and then we have your x plus or minus c right here, right? Your b value from both your secant and your cosecant. And of course, c is your horizontal or your phase shift, and d is your vertical shift. So let's jump into some examples and do some calculations. Okay, it just says find the period. Right, pretty standard stuff for our trig graphs. So the b value in this case is 1/4. Right, that's the number in front of x. So that's what we're going to do. We're going to take our 2 pi, which is your standard period for cosecant or secant, and divide it by 1/4. Okay, and hopefully you don't need your calculator for this. Instead of dividing by a fraction, we would like to multiply by its reciprocal. So rather than dividing by 1/4, we multiply by 4/1. So 2 pi times 4 divided by 1 is 8 pi. So this secant of 1/4 x has a period of 8 pi. Okay, really stretching this graph out wide. Is a very wide graph compared to its usual one. Okay, number 5 says y equals the secant of 1/2 parentheses x minus pi. Well, this is your b value still, and in this case, pi would be your c value. Okay, so we don't use the c when calculating the period, we only use the b. So 2 pi divided by 1/2. Once again, whenever we are dividing by a fraction, we instead multiply by its reciprocal. So the reciprocal of 1/2 is 2/1. So 2 pi times 2 is 4 pi. This function would have a period of 4 pi. So let's switch gears here and look at doing some graphs of our cosecant and our secant functions. Okay, so there are some steps that we're going to take every time we do these, and here are your steps. Okay, number 1, you're going to sketch the corresponding sine or cosine graph because you want to find out what is the maximum values, what are the minimum values, and what are the zeros. Okay, zeros are where your graph has asymptotes. Maxes is where your graph has upward facing parabola looking things. And minimums is where your graph has downward facing parabola things. Okay, so we're going to get these 3 points. Yes, there's lots of maxes and lots of mins. We're going to get the points from our corresponding sine and cosine graphs. Okay, so we'll talk about how we graph those sines and cosines also when we're doing these problems. So let's see if we can apply that to our graphs over here. So our first one says graph -2 cosecant of x. -2 cosecant. So is there a b value Right? I mean, of course there is, but the b value is 1. So 2 pi divided by 1 is just 2 pi. So our graph, our cosecant graph, will complete 1 full cycle by 2 pi. So that means that we come onto our graph and you put a tick mark on your x-axis and you label that 2 pi. Right? That represents 1 complete cycle. And then we're going to come that same distance and do another 2 pi. So 2 pi plus 2 pi is 4 pi. So 4 pi will be the end of our second cycle. So we get our points from the cousin. So the cousin of -2 cosecant is -2 sine. So all we do is we change the cosecant to its sine reciprocal, and that's where we're going to get our points from. So remember, this is a sine graph, and sine has its own pattern. Sine starts at the origin, right? It has a 0 at the origin, and has a 0 at the end, and it has a 0 in the middle. All sine graphs have this pattern. 0 at the start, 0 at the end, 0 in the middle. Okay, so now let's look at the amplitude. We have a +2 amplitude. So we're going to go and make 2 tick marks on the y-axis up, and we're going to make 2 tick marks on your y-axis down. Now, because our graph is negative, that means that our sine is going to go down to a minimum first. Usually sine goes up and then down, right? That's a positive sine graph. Well, a negative sine graph will go down to a minimum, back to a 0, and then up to a maximum. So our first point is in the middle of your zeros, and it's down 2 units. Our next max is in the middle of your zeros, and it's up 2 units. Okay, so we get our points how we have always done from graphing sine. In this case, negative goes down to a minimum and then up to a max. Okay, so we really just want to know where's our minimums and our maxes and our zeros. Okay, the rest of the sine graph, the curvy sine graph, we don't have to put on here because that's really not a part of your cosecant graph. We're looking for your zeros and your maxes and your mins. So now that we have plotted all of those points, your zeros, your maxes, and your mins, we're going to put in our asymptotes. Everywhere that we have a 0, cosecant has an asymptote. So we put a vertically dashed line everywhere our dot is on the x-axis. Once you have all of your asymptotes in there, everywhere you have a maximum dot, you put an upward facing parabola, and everywhere you have a minimum dot, you have a downward facing parabola. Okay, right? They're not really parabolas, they're just helping us be able to graph these with something that we've already done. So that is the graph of -2 cosecant of x. So the last thing to talk about is what is the range of this graph? Okay, what are the possible y values here? Well, because your graph starts off right down forever, we start at -infinity. And then the first highest point we stop at is -2. So our bottom part of our graph goes from -infinity to -2. And then we do a big jump. We jump over the middle there, and we start again at +2. Okay, that's the next maximum value for your sine. And then it continues on up to infinity. Okay, so all of these secant and cosecant graphs will all have a range that has a gap. All right, we have a gap between -2 and +2 where the cosecant doesn't have any points. So it's undefined from -2 to +2. So this is how we write the range as a combination of 2 separate intervals. Alrighty, sounds super. Let's look at another one. A little more complicated, 3 cosecant of 2x plus 1. Okay, So first our period. 2 pi divided by 2 is going to be just pi. Right, so our graph has a period of pi. It's going to be significantly skinnier than your graph that we just had over there. Right, we had a period of 2 pi. But because we don't really mind, we're just going to come over here and we put pi on your x-axis, right? We label the period, which means our second period is going to end at 2 pi. Now you put in your midline. Notice there's a +1. Right? This is your vertical shift. So we go up 1 unit on the y-axis and you put in your horizontal line representing your new middle. Right? This is your new middle of the graph. This is where your quote-unquote zeros will happen. Now let's look at our friend. His friend would be 3 times the sine, which means we have an amplitude or a dilation of 3. So 3 units above your midline and 3 units below your midline is where your maxes and your mins will be. So let's put on our dots for sine. Remember, sine starts at a 0, ends at a 0, and has a 0 in the middle. Starts at a 0, ends at a 0, and has a 0 in the middle. Because it is a positive sign, it will go up to a maximum in between your first 2 zeros, and then it will go down to a minimum in between your second 2 zeros. And that is one complete cycle. So we repeat that cycle as many times as we need to until we have the full graph of our sine here. Now, everywhere we have a 0, everywhere your graph crosses the midline, we have an asymptote. From your maximums, your graph goes up. And from your minimums, your graph goes down. And that's our complete graph of 3 cosecant of 2x plus 1. So let's look at a couple of, oh, wait a second, we have to do the range. Sorry, I forgot about the range. The range for this graph, right? The possible y values are always from negative infinity until this case our least value is -2. Right? And then we make a big jump and we pick up again at 1, 2, 3, 4. Right? 4 is the other side. So 4 to infinity. That is the range for this cosecant graph. Okay, so now let's look at some secants. Here we have a nice secant equation. So let's start with period. Period is always 2 pi divided by b. So 2 pi over 3. Well, that can't be reduced, which means our period is 2 pi over 3. So we put 2 pi over 3 as a label, and then double 2 pi over 3 is 4 pi over 3. So those are your 2 periods on the positive side of your y-axis. Okay, so now we have to put in your vertical shift of down 1. Right, so we go down 1 and you put in a horizontally dashed line representing your midline. And now we have to think of the cosine graph. So this cosine has an amplitude of 1, which means it's 1 unit above and below your midline. So remember, cosine starts at a maximum. So cosine is going to start 1 unit above your middle, which in this case is at the origin. So cosine starts at a max and it ends at a max. And in the exact middle, it dips down to a minimum. So we have a minimum there 1 unit below your midline, or at -2. And in the middle of those, that's where cosine has zeros. So these are your 5 basic points for the cosine graph, right, which we can continue on and fill up the entire page. Cosine starts and ends at a max. It has a minimum in the middle, and it has zeros in the middle of that. So now that we have our points, we can put in your asymptotes and your upward and your downward u's. So there's your final graph. Hopefully yours looks exactly like that, or similar. Okay, so one last example. 2 secant of 1/2 of x. So our b value is 1/2. So 2 pi divided by 1/2 is 4 pi when we multiply by the reciprocal, right? 2 times pi times 2 over 1, so 4 pi. Which means on our graph we come over and we put a 4 pi, and then we put in 8 pi. Okay, our cosine has an amplitude of 2, so we put 2 tick marks on your positive y and 2 on your negative y-axis. Okay, and then we put in your points. Cosine starts at a max, ends at a max, in the middle is a min, and in the middle of those are your zeros. Okay, it's the pattern that we use all the time to graph cosine. Starts at a max, ends at a max, and is a minimum in the middle. And then your zeros. And from those points, now we put in your asymptotes and your graphs. Up from all the maxes, every max we have an upward facing u, and all the minimums we have a downward facing u. Okay, so the range would be from -infinity to -2, right? And then we jump over and we land up +2 again, and we continue on to +infinity. Oh, we didn't do the range here, so sorry. -infinity to -2, and then 0 to infinity. Once again, we're at 0 and the y value. Okay, so there you go. Ranges and graphs. Okay, hopefully this helps. Secant and cosecant. Okay, bye.